Hello everyone, in this class we are going to learn the back substitute method as well as the tree method, and we will see how by using these two methods we can find the time complexity of recursive algorithm or recursive program. Clear? So let's start with back substitute method first. Back substitute method. So let's say recursive equation given as t of n equal to 1 plus t of n minus 1 for n greater than 1 and 1 when n equal to 1. Now what is this t? T is the function taken by the recursive algorithm. What is this t? T is time function taken by recursive algorithm. What is this n? N is number of input. And one more thing, this t is a time function. Now look at here. What does this mean? This means whenever the number of input is 1, at that time this function, the time taken by this function is constant time, that is only 1. That means what does it mean? This means that whenever number of input is 1, at that time the function will take only a constant time, that is 1. Now what does this mean? This means whenever the number of input is more than 1, at that time the algorithm will take this time. Whenever the number of input is greater than 1, at that time the time taken by this function is this one. Clear? Now what is this? We will use this as base condition. Base condition or termination condition. We will see later how we can use this thing. Clear? In back substitute method as well as in tree method. Now let's start. Our first thing is that the function is given as t of n equal to 1 plus t of n minus 1. Let's take as equation 1. Now replace or plug in, let's say replace. Now we replace n by n minus 1 on both sides. What we will get? We will get both sides in equation 1. So what we will get? We will get this n will replaced by n minus 1. So we will get t of n minus 1 equal to this 1 will still 1 t of n. This n again replaced with n minus 1. So we will get t of n minus 2. Clear? How these two will come? Look here, the n will replace with n minus 1. So we will left with like that. N minus 1 we have. Now this n is replaced with n minus 1. So we will get n minus 1, then this minus 1, then this minus 1. So this will give us n minus 2. And that's what we get here. Now again replace. Now look, in this statement, in the equation 1 we have t of n minus 1. That's why we replace n by n minus 1. Now in this particular equation, that we will give it as 2. In the equation 2 we get t of n minus 2. So what we will do? we will replace n by n minus 2 in our expression 1. So let's do it. Replace n by n minus 2 in equation 1. So let's see what we will get. So I erase this thing. Hope you understood that part. So here in the equation 1, again we are replacing n by n minus 2. So what we will get? We will get t of n minus 2, because this n is replaced by n minus 2 now, equal to 1, again 1 plus t of n minus 1. That means this n will become n minus 2, and still we have one more minus 1. So total we will get t of n minus 3. Hope you understood. Now this, let's say this one is number 3, equation number 3. Now next what we will do? Now we will substitute. Now we will back substitute the value of t of n minus 1, t of n minus 2 in equation 1. Clear? Now we apply the concept of back substitute. So first what we did in the given equation we have t of n minus 1. So in this expression we replace the n by n minus 1. So in the equation of n minus 1, t of n minus 1, we get a new term, that is t of n minus 2. So we need to know what is t of n minus 2. Because of that, we again substitute t by n minus 2 in our given expression, and what we get? We get this particular statement. Now next what we will do? We will back substitute all the statement repeatedly in equation 1. Clear? Now next back substitute apply. Back substitute. So first what we will do? In equation 1, first back substitute. Equation 1 we have what we have, that is t of n equal to 1 plus t of n minus 1. Clear? Now in this particular expression, this t of n minus 1 we have. Now we know the value of t of n minus 1. What is the value of t of n minus 1? We know that t of n minus 1 is 1 plus t of n minus 2. We know the value of t of n minus 1 is 1 plus t of n minus 2. So we replace the value t of n minus 1. So what we will get? 1 is still there, plus, because of this t of n minus 1 we will get 1 plus t of n minus 2. So what we will get? 1 plus t of n minus 2. Clear? So what does it mean? This means we get 1 plus 1, that means we have 2 plus t of n minus 2. Clear? Now here we get t of n minus 2, and we know the definition of t of n minus 2. What is the definition of t of n minus 2? T of n minus 2 is 1 plus t of n minus 3. So let's replace again. So what is the value of t of n minus 2? Plus, this will give us 1 plus t of n minus 3, and if we simplify this thing we will get 3 plus t of n minus 3. Now try to observe the pattern in this back substitute method. Try to observe the pattern that we get in this particular representation. What is that pattern? That pattern is like, whenever we minus 1, at that time we get 1 here. Whenever we minus 2 from n, at that time we have 2 here. Whenever we minus 3, at that time we have 3 here. So hope you observe the pattern. Now look at here. In this statement 1 is there and we minus 1 from n. In this statement 2 here and we subtract 2 from n. What is there in this particular statement? In this particular statement 3 is here and we subtract 3 from n. Now look at here. When we substitute first time, at that time we get 2 plus this thing. When we substitute next, at that time we get 3 plus this n minus 3. Now if we repeat this thing for k times, what we will get? We will get k plus t of n minus k. Hope you understood the concept, how we get this term. We can apply k times only when we get to know the pattern that we are following in the back substitute approach. Clear? So to get to know this approach, this pattern, to get to know this pattern, you have to observe the process. You have to observe the result or outcome after each back substitute method. And whenever you get to know the pattern, at that time you can directly apply k times, because we don't know how long we need to apply this method so that we can remove this function t, because we are going to find the value of t, but within the definition of this t we again have this t. That's why it is recursive approach, recursive method. Clear? So to find the value of t of n, we need to remove the value of t of n. We need to remove the function t from its definition. Clear? That is our goal. So to find the value of this function t of n, we need to remove the function t from its definition. That is our next goal. So when we can remove this particular definition, when we can remove this particular function t from this particular definition, only when we can remove this, when the value of t of 1 is 1. When we get t of 1, only at that time we can replace that function t of 1 by 1. Clear? That's why this is called the base condition or termination condition. That's why this is called the base condition or termination condition. So now we get t of n minus k. So but what we need here? We need t of 1. We get t of n minus k, but we need what? T of 1. Why we need t of 1? Because when we get t of 1, only at that time we can remove that function t from its definition. If we get anything else other than 1, t of 1, at that time we need to follow this particular definition, because the number of input n is greater than 1. Correct? So to remove this definition t, we have to know, we need to reach to the value of t of 1. We need to reach to t of 1. Only at that time we can remove the function t from its definition. Otherwise, for any other case, within this definition, within this function t, again t will arise and we can't solve that particular problem. Clear? Because it again repeats. Why? Because this is a recursive function, and each time you will get again the same function, again the same function, again the same function, until you reach to this t of 1. Until you reach to this t of 1. That means to remove this function, to remove this t from this definition, we need to reach to t of 1. Now how can we reach to t of 1? By assume that this n minus k equal to 1. By assuming that this n minus k equal to 1, we can reach to that t of 1. We can reach to our base condition or termination condition. So let n minus k equal to 1. Now what? Now we don't know the term k, so we need to find the value of k here. So from using this relation we will find the value of k. So what will be the value of k here? K will be n minus 1. Clear? Now here in this definition we will replace k by n minus 1. In this definition we will replace k by n minus 1. Let's see what happened. So let's come here. So what is the value of k? K is n minus 1. So t of n we will get n minus 1 plus t of n minus k. What is k? K is n minus 1. So t of n minus k means n minus 1. So this is what we will get after we replace the value of k by n minus 1. And how we assume that n minus k is 1? Because we need to reach to t of 1 so that we can remove or we can replace the function t from its definition, so that we can remove the function t from its definition. Clear? If we are not able to reach to t of 1 at that time, again if we apply back substitute, again it comes, again the function t arises. Why? Because this is a recursive function. Clear? So we have to reach to this t of 1, and because of that we assume that t n minus k is 1, and because of that only we assume that n minus k is 1. So from this relation now we will find the value of k. So what will be the value of k? Value of k will be n minus 1. So now in this particular expression, in this particular definition, we will replace k by n minus 1. In this particular definition we will replace k by n minus 1, because now we know the value of k. So what we get? We get n minus 1 plus this thing. So we just simplify some n minus 1 plus t of n minus 1 plus 1. Sorry, n minus n plus 1. That means this n gone. So we left with n minus 1 plus t of 1. Now look at here. Now we reach to t of 1. So what is the value of t of 1? T of 1 is 1 only. So we can replace n minus 1 plus t of 1. Value of t of 1 is 1 only. So we get 1. Now n gone. So we will get t of n is n. So what will be the time complexity of this particular recursive equation? Of this particular recursive equation, the time complexity will be t of n equal to, time complexity will become order of n only. Clear? So that is how we can use the back substitute method to find the time complexity of recursive algorithm. Now, where is the toughest part in back substitute method? In toughest part is to observe the pattern here. Observe the pattern. Observation is the toughest part here. Nothing else is tough or hard. Nothing else is hard in case of back substitute method. Hope you understand the concept.